Welcome everybody. So, game plan for today. Students bridge the connection between factoring, zero, and graphing. So for the past 2 weeks, we've been graphing and we've been factoring and you've been saying, Mr. G, why have we been doing all this factoring? And today we're gonna make a lot of connections. So what I want you to do for a warm-up is, I want you to just factor completely these 3 polynomials, okay? Try and pause the video and do it by yourself, but if you want to see how it's done, here, let's see, for the first one, can we factor out a GCF? No. So then here, what's our rhythm? What 2 numbers when you multiply give you -12, but when you add give you -1? It's going to be x minus 4, x plus 3. Boom, done. Okay? What about this one here? Can we factor out a GCF? Yeah, we could factor out what's the GCF of these 3 terms. It's an x. So we could say x times x squared minus x minus 12, right? We just x is the GCF, so we just factor out an x. And then here, oh look, doesn't this look very familiar? Yes, you could just factor this again. So this is x times x minus 4, x plus 3. So you see here, we factored once, then we factored again, okay? Let's look at the bottom one here. Here we have 4 terms. So what's a nice technique to see if it's possible to factor out? And that's factor by grouping. So if I were to make my first 2 groups, what's the GCF of this group? It's x squared. And if you factor out x squared, it becomes x plus 5. And notice if I have an x plus 5 here, we hope to get an x plus 5 here. And how can we do that? We can factor out a -4, and this becomes x plus 5, and bam, look, we have 2 common binomials, and what we could do is we can say x squared minus 4 times x plus 5. And I guarantee you, I already know some of you are thinking, oh, Mr. G, we're done. Well, the thing we need to look at is, can we factor this more? No, we can't, but can we factor x squared minus 4 more? And yes, you can. This will be x minus 2, x plus 2, and times x plus 5. And for some of you who are thinking, oh, Mr. G, I never learned this technique, these are the techniques after AC method that you need to catch up on. But remember, this factors more, because the idea is, the question is saying factor completely. And here, this is as much as we can go. Okay, good. So after the warm-up, let's take a look at the essential questions that we want to explore in this lesson. Here, let's look at the first question, right? If I have x squared minus x minus 12, and I want to know, let's say if I make this equal to 0, I want to know, hey, what number can I plug into this polynomial so after I do all the operations, it equals 0? If such a number exists, okay? So which value of x makes this whole thing equal to 0? That's what we want to look for. And here, the second thing we want to make the connection of is, what does this graph look like? How does maybe what we've done before make a connection with the graphing, okay? So here, let's take a look at this. If I wanted to find which value to plug in and somehow this whole thing becomes 0, what you want to do is you want to factor, and then you want to use something called the zero product property, okay? And I will explain what this means. So let's see, if we factor this, then how does this factor? Well, we just did it over here, right? It's x minus 4 times x plus 3. So it's x minus 4 and x plus 3. And we say that it's equal to 0. Now, the zero product property, what it allows us to do is, if we have 0 on one side, we're allowed to say x minus 4 is equal to 0, and x plus 3 is equal to 0. And now here, if I solve for x, how do I get x by itself here? If I do plus 4, x is equal to 4. And if I do minus 3, x is equal to minus 3. What does these 2 values of x represent? They answer that essential question. If I plug in 4 into this polynomial, it will give me 0. If I plug in -3 into this polynomial, it will give me 0. Let's just check. Let's plug in 4 into here and see what happens. Try and do it by yourself. Pause the video and try and plug both of these in to see if we get 0. And if you want to see how it's done, if x is equal to 4, right, let's plug it in. So this becomes what? 4 squared minus 4 minus 12. Hopefully it equals 0. So 4 squared is 16, minus 4 minus 12 equals 0, question mark. Let's just see. Well, what's 16 minus 4? That's 12. 12 minus 12, it does equal 0. So big happy face, right? We answered that essential question. And if you plug it in for -3, it will also work, all right? Now the next thing we want to do is, what does this graph look, what does this polynomial, x squared minus x minus 12, what does it look graphically? And is there a connection between factoring the polynomial, finding the values that make the polynomial equal to 0, and with the graph? So what I want you to do is, let's grab our calculator over here, let's turn it on, and the first thing that you should do is reset the calculator. So how do you reset the calculator? Just follow this. Second plus. You're going to have this list over here. We're going to go to reset. We're going to go to all RAM, enter, and then you go down to reset, and then bam, the RAM is clear. So then now how do I see what this graph looks like on the calculator? Well then this is what I'm going to do. I'm just going to go to y equals, and then I'm going to have this, I can plug in my equations. So let's see, where is my variable x? This is x squared minus, minus x minus 12, okay? And let's hit graph. And then this is the graph. And then one thing we want to notice is, let's see, where does the graph hit the x-axis? Notice it hits where? It hits, if this is my 0, let me zoom in a little bit. If this is the origin, right? Let me fix this a little bit. Okay. Okay, there we go. Here, this is my origin, and look, I need to go 1, 2, 3 to the left. So I know it hits here, and I'm gonna go 1, 2, 3, 4 to my right, and it hits here. And then notice that here, this is x equals -3, and this is x equals 4. But look, this is the connection of factoring the polynomial and solving it. It's this 4 is here, and this -3 is here, and I know my graph has to hit those 2 points on the x-axis. Okay? This is a very powerful thing we can do to help solve and factor polynomial equations. All right? What I want you to do is, let's take a look at this definition over here, that the place where the graph hits the x-axis, right? These are the zeros or the roots of the polynomials. It's saying that, like, let's say if this is my polynomial, f of x is equal to something, whatever that polynomial is, if this is -3 and this is 5, for example, if I put in -3 into my f of x function, the whole thing becomes 0. If I put in 5, the whole thing becomes 0. These are called the roots or the zeros of the polynomial. So where they intersect on the x-axis will show which values of x make the whole polynomial equal to 0. Okie dokie. What I want you to do is, let's take a look at the next one. Here, same question as number 2, right? From the factor, from the warm-up. If I have this polynomial and I say, hey, which values of x make this whole thing equal to 0? Okay? Try and do it by yourself. And what I want you to do is graph this polynomial in your calculator and see what it looks like visually, and let's see if we could bridge the connection. Okay? Try and pause the video and do it by yourself. But if you want to see how it's done, let's just, what's the first move? Always make sure we have 0 on one side. Okay? Right now you're saying, oh, Mr. Zero's already there, but just remember that. Okay? Move 2, factor completely, if possible. Okay, so let's factor. How did it factor? It was something like this, right? Okay, and then we have to factor again. So x minus 4 x plus 3, right, equals 0. Now we have to apply the zero product property. So we're going to say that x minus 4 equals 0. We're going to say x plus 3 equals 0. And we're also going to say, don't forget this guy, the original thing you factored out, we're going to say x is equal to 0. So then here, if we solve for it, x is equal to 0, that's one of them. What's the other one? Plus 4, x equals 4, okay? This is minus 3, x equals minus 3. What do these represent? Whatever my graph looks like when I plug it into this calculator, I know my graph has to hit these x values on the x-axis, okay? So let's take a look. Let's plug in the original. If I go to y equals, we could clear the original one. Let's see. X, and if I want to raise it to the third, you see this above the division symbol, this caret symbol, I hit caret 3, and this is saying x to the third. Then now let's plug in the rest. This is minus x squared minus 12x, okay? And let's see what this looks like. If I hit graph, okay, so let's say if I want to zoom out a little bit. Let's just do a little zoom out, okay? So our graph kind of looks like up, down, up, all right? Let's zoom back in, okay? And notice, hopefully we have this connection. Where does this graph hit the x-axis? Look, it hits at minus 3. So I know it hits 1, 2, 3 at minus 3. It also hits at 4. So 1, 2, 3, 4. And also it hits at 0. And that's where the original x that you factored out, it hits at 0. So it hits at these two places. So I know my graph looks something like this. Okay? And this graph represents this polynomial. And here, these represent what? The roots, or the zeros. And we calculated that by factoring it and using the zero product property. Okay? What I want you to do is try and do this one by yourself as well. Go through and explore with it. And then here, I want you to pause the video, and then once you're done and you feel good, I want you to solve for x and graph each polynomial to make that connection. Okay? I'll see you.